Hey everybody, what is going on? Welcome to the 20th Scikit Learn with Python for Machine Learning with our investing example tutorial video. In this video, what we're going to be doing is building a backtesting kind of functionality to our machine learning testing. So generally with machine learning testing, you think of it as you train, then you test, and your answer from your test is your accuracy or how good that algorithm worked for you. But with investing, that's not really the case. You need to know your performance. So the accuracy is one thing, but as we brought up in the previous video, accuracy is only one little bit of investing or trading in the stock market. Accuracy matters, but so does performance. So just because you're 80% accurate does not mean you're a profitable trader, even though most people tend to kind of value, in general, accuracy. Although most firms and stuff tend to value performance, maybe even too much without calculating in risk. So, and that's another topic entirely. This strategy is, I would say, fairly low risk, but we need to calculate risk and actually do a true risk assessment of the strategy to kind of see how secure this strategy really is, because you always have to account for risk. And actually, probably most people pay too much attention to accuracy, too little attention to the actual performance of the accuracy, and even less attention to risk. Like, a lot of people just don't care about risk. High risk, high yield is like the most popular form of trading for the amateur, and yet the amateur almost always loses. So it's kind of strange how people like to ignore risk. But anyway, so in this strategy, however, there's not too much risk, or at least not too much inherent risk that I see. But anyways, let's make this backtester. Enough of yapping. So basically we only need one thing here. We're just going to import statistics. And we're importing statistics to get a quick average. And that's pretty much it. So now in the build dataset, currently we return an x and a y. I'd like us to also return a z variable. And the z variable is going to equal the numpy array conversion of data underscore df. And then within here, to specify two columns, what you do is say, like, normally to specify a column, you could specify the status column by doing this. But in pandas, you can specify multiple columns by, within this kind of indice question, you add another set of square brackets, and now you can add basically a list of columns. And the list that we want is stock underscore p underscore change. And we also want sp500 underscore p underscore change. So we can take this percentage change, because really what we're concerned, we don't really care what the prices were at all, actually. We just care about percentage change, because we're basically going to say we invest 10,000 into the market or we invest 10,000 into the stock. What's the percentage change? How did we do? So those are the only two values that we actually care for. So we're going to take that, and then at the end of this, we return also a z variable. So we're returning an x, a y, and a z. So we need now to basically unpack all of this data. So we come down to our analysis where we call x, y. So now we're going to call z. And that's that there. And then now what we want to do is for x in range here. First we ask if CLF predict is the case where this is our correction, so our accuracy calculation. Cool. Now we need another if statement, and this statement is going to be if it's a 1, right? If the stock value is a 1, i.e. we are predicting outperformance, then we want to make an investment, right? Period. So what we would do then is if CLF.predict basically this right here, so we can pretty much just copy this whole line, paste, not the whole line, sorry. So if CLF.predict, that 0th element basically, if that prediction is that it's a 1, i.e. an outperformance, what do we want to do? Well, we would like to make an investment. So now, in fact, we need to add a few starting parameters here. So test size is 1,000, that's fine. We're also going to add invest underscore amount, and this will be the amount that we invest each time. We'll just put 10,000, you could put 100, you could put 1,000, you can do whatever you want. We're going to put 10,000. Then we're going to account for total invests, and that's going to just be the total amount of times, the total amount of trades that we make. Later on, we can multiply this by a trade cost or something like that and subtract that from our earnings. So anyway, total invest. Also, this we're going to have an if market, and that's going to be equals 0, and then if strat, and that will be equals 0, and this will be calculating whether or not basically if market is going to calculate if we took all, like, because we're going to have to calculate both what was the return on investment if we just bought like the S&P 500 index. So you can buy like the SPY, right? You can buy that, and that's an ETF for the S&P 500, so you'll see the same performance. So you could buy that if you invested in the market, or we're going to calculate how much money you have at the end if you invested with the strategy. So that's that. Now we are going to come down here back to our prediction basically, and we're going to say the following. We're going to do invest underscore return. The investment return is going to equal the whatever the investment amount was. So that's the starting amount plus the percentage change times the investment amount. So it would be 10,000, let's say, plus what was the invest underscore amount times, and this will be the z of the negative x, right? Because we're working with negative x here because we're moving back those elements. So z, oh man, I'm kind of lost now. Hold on. Okay, yeah, z, the negative x of the 0th element, and then divided by 100. Okay, so that is basically the z minus x 0. That means that if, let's go up to the very top here, the 0th element, right, of that z of the negative x indice. I'm having a really hard time explaining this. So this is obviously a list of lists, right? There's actually an array of arrays, but anyways, or just an array. Moving on. So Z has stock price and then the S&P 500. So when we do minus X, that's the specific one, and then that gives us basically one example of this and this. So the 0th element will be the percentage change of the stock, and the 1st element will be the S&P 500's, the market's change. So the investment return will be this number, and then basically we can take the same line pretty much, and we'll call market return. Market return. It'll be the investment amount plus the investment amount of the z of the x minus x rather, and then the 1st version of that for the market, and that's that. Next, we're going to say total underscore invests plus equals 1, and then we're going to say the if market investment, and then we're going to say plus equals the market return, and then the if underscore strat, it was if strat, right? Yeah, if strat, plus equals invest return. Okay, so that's that. That all looks fine and dandy. So we'll come down here, and we've got accuracy. That's totally fine. And now we're going to go ahead and print some of the statistics. So let me get some coffee. Okay, so some of our statistics, we're going to have total trades. So we'll say total trades, and the total amount of trades will be total invests. Then we're going to go ahead and say what the ending values are. So ending with strategy, we'll do if strat like that. Let's do a colon here. And then we're going to just copy and paste this market, or this line rather, and replace strategy with market. And then if market. Okay, so those are our ending values. And then now what we want to go ahead and do is do like a comparison. So what we'll do is we'll say compared, and that's going to equal if underscore strat minus if underscore market. So that's the difference of the strategy compared to the market. So that's our difference divided by if underscore market. I guess we could actually do if strat there. I guess we're comparing it to the market, so we'll do that. If market, and then we basically encase all of this in parentheses, and then multiply by 100. Then what we're going to do is we're just going to print compared to market, we earn, and then we earn string compared plus percent more. Actually, that's not necessary. More. Then we're going to come down and we can actually take the percentage of total, like the total percentage of all of our investments. So we can say average investment return, and the original code I wrote for that, I'm not really actually happy with that. So for the average investment return, what we would really need to do is we'd need to say, you know, we need like an if nothing, basically. I'm not going to touch that for now, actually, because we do have the compared to market, so that's totally fine. We'll just leave that for now, and we'll come back to that, because the average, originally my code was the mean of the entire z element. That's not useful. So yeah. Whoops. So let's go ahead and save and run this real quick. Let's see what we end up with. I can't remember if we're doing the full one or not. Ah, we're doing the full one. We should do no not available. We'll check that one next. Especially if we get an error. Okay, so had we invested in the market, we're being told that we would have actually we would have made basically 919 trades. So that would have given us 9.7 million, as opposed to the 10.6 million that we would have made with our 919 trades at 10,000 each. Compared to the market, we did 9% better. That's quite nice. Now let's go ahead. I want to add this now. So we've got total invests equals 0. So what we'll end up doing is we'll say, I guess, do nothing. Do nothing equals total invests times invest amount. So that would be like the total amount of money we'd have had we done absolutely nothing at all. And then what we can do is do the following. So we can say average market return would be, just try to make sure this makes sense, because otherwise, like, yeah, should be fine. Right, because we have compared to market. Yes, average market return would be new minus the old divided by the old times 100. So we would say new if market minus the old do nothing. New minus the old divided by the old do nothing times 100. Let's add our parentheses now. New minus the old divided by the old times 100. So that's average market return, and then we'll do average invest. I don't know. Not sure what to call that. Average strat. That's what we should call it. Average strat, and then if strat. So that's average market, average strat, and then now we can say average investment return colon string avg strat plus percent, and then let's just copy and paste this line. Average market return avj market. Okay, let me run this. We'll change this to no, not available for now, just in case we do throw an error. It's a little quicker to develop with this one. Okay, so the average market return, that's good. 12.9, we know that to be the case. So had we taken our money and invested into the market over the course of 10 years, each return would average out to 12.9, which again, that's right in line with what the market's returns are. So that's good to see. and the average investment return is 19.4, and we can see that our difference here is 5.7. So so it's good, and we can see that although this time around we had no not available data, so now let's throw in with the not available data. Actually, let's run a couple of tests clean here with no not available. I'm just gonna run let's just run a few. So we're seeing that we're hovering around 6-ish%, although that was a 7.2 with more trades. Interesting. 611 and 6.7. So I don't know, like 6.5-ish. I don't know, somewhere around there is our average without using not available data. And then now let's throw in with the not available data. So bring this over. This might be a while. Okay, so we got a 7.2 with our not available data. Or 7. Sorry, I looked at the wrong value. 6.7. Hopefully I wasn't looking at the wrong value last time. Oh man, we killed the market now apparently. What is it? Is this our? This is with our not available data, claiming the average market return is an 8 or 7.95, which I don't think is the case. It'd be interesting. Pretty sure the market on average over the last decade would be 12%. I have to look. Let's do one more. Waiting on this last one. Okay, so our average investment return, however, is generally about 18-ish%. We did get a 14 on the first one, but we're seeing 18, 17, 18, stuff like that. So, so whether or not we're using with NA or no NA, we're seeing significant around 7-ish outperformance of the market. So, so what now? There's a lot of other things that we have to account for. Probably the most massive thing that we're not accounting for here, it's not trade cost, it's not anything, but the fact is that let me see here. We have itchy eyes. That's what we're forgetting. No, I don't feel like coding it right now, but the total amount of stocks that we're trading on is about 340 companies. We started with about 500, and because of whatever happened along the way, either the original data set didn't have it, and then we didn't have the stocks like Toyota, for example. We couldn't get stock prices on Toyota for some reason. That kind of stuff, we slowly throughout this entire process have kind of whittled out companies. So the next thing we really want to be able to do is do the entire, say, Russell 3000 of companies using this exact same structure and see what we can find. So this information might be available on Quandl, so all of these kind of data sets, and maybe a paid data set. Another thing that we can do is we can look through Edgar on the SEC website. There is an API, so I'll probably play with that in one of these videos eventually. So we have all kinds of options now for kind of expanding this, because getting back to my original point, our biggest problem is to acquire this data set. This data set is based on the companies in the S&P 500 in the year 2013. And then what we did was we did a back pull of historical data from Yahoo based on those companies that were still alive in 2013. The problem is that any company that was alive in, say, 2002, or at least was within the S&P 500 in 2002, is not being included, right? And there's only two ways that you would exit the S&P 500, or there's really only one reason you would exit the S&P 500. Actually, I guess there's two. All right, one is you go private. Okay, so you just buy out and you go private, or two, you tank, right? Your price falls enough to where your market cap kicks you out of the S&P 500, and so that's not very good. So a lot of the companies that exit the S&P 500 are underperforming companies. So we've probably knocked out already before we even begin this test. We've knocked out a lot of the underperforming S&P 500 companies. And the problem is we've knocked them out, but the S&P 500 index has not. Okay, so as that company leaves, another lesser company comes in to take its place. But bottom line, that was a lesser company at one point, and now it's kind of performing well or whatnot. But as the company that gets kicked out of the S&P 500 begins to fail, it's actually dragging down the S&P 500. We're not accounting for that. We're only testing. See, like we're testing against the S&P 500, which is impacted by these bad companies that went out, but we're not actually trading against those companies. So that's a problem. So really what you'd want to do is maybe every year or every quarter reassess what companies are actually in the S&P 500, get the stats on those, and see, like, would we have invested in those? Because ideally, if they get bought out, who cares, right? That's totally fine. If we had invested in that company and they get bought out, we don't really mind about that. But if say, what we want to know is whether or not we would have invested into a failure. So let's say a company goes bankrupt, stock goes to zero, or let's just say the company makes really, some bad choices or whatever, and the stock significantly declines. Okay, so, did we invest in BlackBerry? Okay, so those are the questions that we have to ask ourselves, and this has not really hit those serious questions. So you have to account for that. So yes, our performance here is actually really good, and that's exciting. It really is, especially considering the very basic data set that we're accessing here. But you do have to understand that I wouldn't necessarily suggest you go out and use this strategy. Actually, I would definitely suggest you don't. Please do not blame me for your losses. But it's exciting to see these kind of results, and there's no doubt in my mind that you can use machine learning to help you invest. It's going to be less biased than you are, that's for sure. And I'm always a fan of buy and hold anyway, so I like this strategy. It's kind of a neat strategy. So anyways, moving forward, the things that we kind of can think about is, with this strategy, we've basically built this strategy around what? Around Yahoo Finance. So what could we do now? Well, we could parse Yahoo Finance from here, and using our trained data, we could parse the S&P 500 of stocks on Yahoo Finance right now, and we could get returned a list of companies that are currently marked for outperformance. So we could do that, and we could find out right now. Of course, you'd want to check for, not only is it, because you basically want to get that company right when it's marked for outperformance, not every step of the way. But of course, for us, we are kind of doing that even in our script. Every step of the way, if it's still an outperforming stock, in the next year or 5 months that we reassess it, we're going to buy more. So anyway, that's what's happening in the backtest anyways. But yeah, we can convert this script to now scan Yahoo. You could do it, say, every day, every month, whatever, and scan Yahoo and find your new investments. And really, you could scan Yahoo and save that data so you can use it in your testing after a year has gone by and stuff like that. So anyways, that's it for now. If you guys have any questions or comments on this video, please feel free to let me know. Otherwise, as always, thanks for watching. Thanks for all the support, the subscriptions, and the donations. And until next time.